It says, suppose 1.2 grams of nickel 2 bromide is dissolved in 250 milliliters of a 41.0 millimolar aqueous solution of potassium carbonate, and it wants the final molarity of the nickel 2 cation in the solution. So the first thing we need to do here is look at the chemical reaction that's occurring. We have NiBr2, nickel 2 bromide, aqueous, in a double displacement reaction with potassium carbonate, K2CO3, aqueous. So nickel goes with carbonate. Carbonates are generally insoluble, and we get NiCO3 as a solid precipitate. And KBr, which is soluble, aqueous. Since we have 2 potassiums and 2 bromides, we get 2 KBr. Now, in some other videos on this channel, you can find more extensive details about how to write out a balanced double displacement reaction. That's not the point here, so I just went through it relatively quickly. So we have a lot going on here. We're given a mass of nickel 2 bromide, and then we want to essentially find out how much will precipitate as nickel carbonate. And then whatever nickel 2 plus is left in solution, we could, if any, we could find its molarity. So the first thing we want to do is we want to find the initial moles of Ni2+. So we want to find how many moles of Ni2+ are in the solution. So we take 1.27 grams of NiBr2 and we convert it to moles. 1 mole of NiBr2 per its molar mass, which is 218.50 grams of NiBr2, times, we want to know the amount of nickel 2 plus. Well, there's 1 Ni2 plus for 1, I guess mole, it should be 1 mole of Ni2 plus for 1 mole of NiBr2. Note that if we wanted to find the amount of Br minus, we would have to have 2, because there's 2 Br minuses for every NiBr2. But in this case, it's 1. And we find out that we have 5.81, where that's the sig fig, 24 times 10 to the minus 3 moles of Ni2+ in this solution initially. We then add some potassium carbonate, and we need to figure out how many moles of that Ni2+ will react. So we need to find out the precipitated moles of Ni2+. And then in the end, the final moles, if we could see it down here, the final mole of Ni2+ will equal the initial moles of Ni2+ minus the precipitated moles of Ni2+. So this is how we're going to find the final moles. Well, to figure out how much precipitated, we need to use our K2CO3, our potassium carbonate solution. So we're going to go from liters of potassium carbonate to moles of potassium carbonate to moles of NiBr2, and then to moles of Ni2+, because these are going to be equal because there's 1 mole of nickel 2+ for every mole of NiBr2. So we want to use liters of solution, not milliliters. So we start off with 0.250 liters. Note that it's 250 milliliters, so we divide that by 1,000 of K2CO3 times, the next thing we want to do is convert those liters to moles. Well, there's this many millimoles per liter. So for every 1 liter of K2CO3, there's 0.0410 moles of K2CO3 times, use the balanced chemical equation, for every 1 mole of K2CO3, there's 1 mole of NiBr2. So we went from moles of one to moles of another using the balanced chemical equation. And then finally, for every 1 mole of Ni2+ in 1 mole of NiBr2. And we find that we should precipitate 0.01025 moles, where that's a sig fig of Ni2+. Now, you can instantly notice that we precipitate. This is 1 times 10 to the minus 2. This is 5 times 10 to the minus 3. So this is a bigger number. So we actually precipitate more than we have. So the final molarity of Ni2 plus is 0. But if it wasn't, what you would want to do is take the initial moles, 5.8124 times 10 to the minus 3 moles of Ni2 plus, minus the precipitated moles, 0.01025 moles of Ni2 plus. And when you do this, you get a negative number, which is negative 4.44, I guess, times 10 to the minus 3 moles of Ni2 plus. Since this is a negative number, or said another way, more precipitates than there is present, the final concentration here, the final concentration of Ni2 plus is 0 molar, because there isn't any left, okay, because this is negative. However, if there were more moles initially than there were finally, and you subtracted these and you got a positive number, then you would simply take that number of moles, divide by the total volume of solution, in this case 0.25 liters, and find the molarity. And in some examples, you will have to do this. But in this particular example, you actually have more precipitated than there was present. Said another way, Ni2 plus is the limiting reagent in this particular example.